So graphing linear equations and including function notation when you graph those. So we talked about this last week or the other day, I can't remember when it was, but if you have an equation that's set up like this, it's in what's called slope-intercept form because you can see the slope. Remember, the slope is always with x, and you can see the y-intercept. So we will be soon talking about other different ways that you can write the equation, but this is currently written in slope-intercept. So the -2 again is the slope, and then the 4 is our y-intercept. So you always, when you're graphing these, you always want to start with the y-intercept because that's telling you where to start. And then you always move up or down from that point. So if my y-intercept is at 4, 1, 2, 3, 4, that's my y-intercept. And then if my slope is -2, remember, any number divided by 1 is just that same number. So -2 over 1. I like to do that just so that I can remember rise over run, how much it's going up or down, and how much it's going over. So since it's a -2, it has a rise of -2. Instead of going up 2, I'm going to go down 2, and then I'm going to move over 1. Move down 2, over 1. Remember that all this means, and this is what we've been talking about, is the rate of change. For every 1x, you're moving down 2. So for every 1x value, I have to move down 2 and over 1. For every x, I need to move down 2 and over 1. And the over 1 part is because you're moving over 1 x value. Remember, rate of change. Okay, so that's as far as we can go. I guess I can go a little bit further down here, but that's as far as we can go now. That is our equation of our line. Remember, the slope always tells you how much to move down and over, or up and over, and then the y-intercept tells you how much or where to start. Again, you could draw your little skateboarder. They always start on the y-intercept, and then when you move from left to right, since it's a negative slope, it needs to go down. So moving to the right, he needs to go down, or she. It can be he or she, I don't care which one it is. Okay, so that's that equation. Now, using function notation, it's exactly the same, except for instead of writing a y, we write f of x. Function of the input equals 1/2 x minus 3. Let's go right there. Just because I know that my y-intercept is -3. So again, the slope is 1/2. And the y-intercept is -3 on this one. So I'm going to start at -3. 1, 2, 3. That's where I start. And then my slope is rise 1 and run 2. So go up 1. Because it's positive, I need to go up. This one was negative, so I had to go down. This one's positive, so I need to go up. So up 1 over 2. Up 1 over 2. Up 1 over 2. You can also continue the other direction. I can also go down 1, back 2, down 1, back 2. It needs to be the same line. And that's as far as I can go. Again, you can draw your little skateboarder to check it. If he moves to the right, he would be going up the hill. I always think of the line as a hill. Okay, So that is all you have to do. My computer went to sleep, sorry. So make sure that you pay attention to the slope. I've seen a lot of people over the last little bit getting this backwards, where they'll move down 1 and over 2 when it's supposed to be down 2 and over 1. So I did want to do a -2, and then I wanted to do a 1/2 just to show the difference.